So just like when we talked about enthalpy, in looking at entropy, we can look at entropy under standard conditions and get a delta S for a reaction that is related to standard conditions. So what's really great about this is that it is exactly like our delta H standard reaction. The definition of standard state is the same, and the values are in your very favorite appendix. So in your appendix, one of the columns that we've not yet used is the standard enthalpy for a substance. So if we wanted to calculate a delta S under standard conditions for a reaction, it is a state function. We can do products minus reactants. And the equation looks exactly like your delta H equation. So the standard delta S reaction is equal to the sum number of moles of products times the standard, it's usually the molar entropy, the standard molar entropy of the products minus the sum number of moles of reactants times the standard molar entropy of the reactants. So this is the equation that we will use for this. Now, remember to watch units, because again, the entropy units are going to be in joules per Kelvin. And if you need to combine this, say when you calculate delta G, your delta H units are probably in kilojoules. You can convert in whichever direction you like, as long as the units match when you add them together. And remember that we only have zero entropy at 0 Kelvin, and standard conditions are 298 Kelvin. So nothing will have a zero value for entropy. So our standard molar entropy for elements is not zero. All right. Now, if we have everything in the standard state, we just got the equation for a delta S standard. We previously had an equation for the delta H standard. So if we're doing delta H standard minus T delta S standard, well, our delta G can also be listed as a standard. So this sets you up to be able to do a number of things. So one is that if you are given a reaction, you could use the enthalpy of formation values to get delta H reaction. You could use the molar entropy standard to get a delta S standard reaction, and then use these together at 298K for under standard conditions to calculate a standard delta G, which is great. I mean, this is a useful value for us to have, but there's one other column in the appendix that we've not yet used. And if you go look at that, you'll see that it's actually a delta G value. It's a delta G of formation. So just like delta H formation, this is related to getting the elements or getting the compound from the elements in their standard states. So the delta G formation has already been created to incorporate delta HF and this standard entropy. Well, if all of this stuff is a state function, all of those things are incorporated. If you don't need the intermediate pieces, if you don't need delta H reaction, if you don't need delta S reaction, you can get delta G reaction exactly how we got those other pieces. So you could do the sum of the number of moles of products times the delta G formation of the products minus the sum of the number of reactants times delta G formation of reactants. It is a state function. It has everything incorporated, and it is entirely up to you which way you get these. Now, as you know, with test questions, you're really very likely to be asked first to find delta H, and then part B will be to find delta S, and then part C will be to find delta G. But if all you need is the delta G value, you can get it directly from here. There is one last bit about manipulating reactions, but these are rules that you already know and have used. So we are going to put this out here very quickly. We're talking about manipulating reactions and your delta G reaction value. The rules are exactly the same as delta H. So same rules as delta H reaction manipulations. So there is a video for this, so you should go back and remind yourself if you need help with this. I will summarize it. So if you multiply by a factor, then you multiply delta G by the same factor. If you reverse a reaction, you change the sign. So if a reaction is favorable in the forward direction, it is not favorable in the reverse direction. And if you add reactions, you add the delta G values.